Okay, I will just kick it off then and welcome everyone to the CodeMonk space here in our Kosy office. So as you can see, we have built a pretty cool place here for you all today. We even have a terrace outside and a pool that we get to try later. I think it's amazing that some people already brought the floaty into the town hall, so that's pretty cool to see. Before jumping into the pool later and jumping into today's topic, I want to share a little bit about me and about CodeMonk. So my name is Johanna, and I work with marketing and partnership here at CodeMonk. So if you don't know already, CodeMonk run a developer community and a platform for companies to connect with tech professionals worldwide. We have a unique platform where you can hire and manage your technical team. And for all developers out there, we have a marketplace where you can find possibly your next dream job or your next project in tech. So we are here in the Kosy office today, and I have also Sam with me. He is the co-founder and CTO of Kosy office itself. Been one of the key sources to creating this amazing product. So welcome, Sam. I think you're here with me on stage, so I'll leave it to you to tell a little bit about yourself and about the topic of today's webinar, and then feel free to kick it off.
All right, great. So hello, everyone. Welcome. Thanks for joining. What I want to take you through today is first, of course, I'm going to speak just a little bit about Kosy. And then what I want to speak of is a journey we had regarding scaling as we gain more and more users and tried out various technologies. I think we learned a lot. We had an interesting journey. And the piece of the journey I want to speak to you of today is how we were looking at serverless and Docker and some of the decisions we made along the way and the story that comes out of it. I think can be some valuable learnings in that. I've presented, I've put together some slides to make sure I don't forget what I'm talking about and to make sure it's not boring. So let's dive right in. The first thing I want to speak of is so Kosy's journey to scalability. So what is Kosy? You're all in Kosy right now. So we're doing an event here now. But Kosy is mostly a communication platform for effective communication for remote makers. Now it says makers. That means mostly people with boots on the ground who make things. For example, software developers. So we are kind of the target audience of the platform. And the thing is that if you're working fully remote, then you've got Slack, you've got Zoom, but you also need something a little in between. And it kind of looks like this. This is what it looks like. Streamlined, professional. You've got text chat in there, and voice chat, and video chat, and you can do events in here. I think the real value from Kosy comes also kind of when you personalize it. It might end up a little messy like this, depending on sort of like what style you like for your company. You can do it messy or you can do it dry. Um, it's fun to be in. And how does Kosy work? It's like the idea is to have everyone at your fingertips sort of all day long while you're working and while your hours overlap with the other people. You get a lot of visibility and context, like what are people up to. For example, I can show you the screenshot I took earlier from our own office. You can see that we've got two of my colleagues are having a conversation there in the one-on-one room, so I know basically, should I walk up to them, yes or no? Can I just start speaking? Should I send them a text message and have expectations around are they going to respond immediately or not? Which is a lot of context that you kind of don't have when you're working remotely. What are these people doing? Who are they doing these things with? What's their status kind of right now? And from this, you can kind of derive how you want to speak with other people, and it helps you be a lot more efficient. We also put, let's say, cross functional people together in rooms, so it's really easy for the QA to ask the developers questions or for the developers to ask the product owner questions, stuff like that. Just those quick communication things, it solves for really easily. Once you've got this, you're going to notice that the barrier for asking things is just lower. We've also got in-app collaboration, so you can open something like Miro directly inside Kosy and then have the videos of people next to it, which is really nice for those like breakout sessions, brainstorm sessions, or yeah, all of those similar things, retrospectives, these kind of stuff. So yeah, that's kind of what we do, and that translates to certain technical needs, of course, which is the topic of the talk. So we've got real-time bi-directional communication. This means real-time means it has to go fast, and bi-directional means I want to speak from the client to the server, but also from the server to the client. The thing is, if I unmute, everyone needs to know that instantly and not 2 to 3 seconds after I unmute it, or you're losing some audio, right? So all of these things need to happen really quickly, and therefore real-time bidirectional communication. And the server needs to be able to send messages to the client, and you can't just solve that with polling. Um, we've got a high operational complexity because we've got this 2D stuff, we've got voice, we've got video, we've got people moving around in real time, but we've also got people that are moving in different sections that are doing things that are not very real time. So there's a lot of different parts to this application that pieces it together technically. And this is more complex than, say, something like the first version of Twitter was probably a lot less complex than the first version of Cozy. Not that I'm saying Twitter is easy, but there's just a lot of moving parts there. Also, it means we've got strong privacy and security requirements because company are doing all of their core internal communication on Cozy, or like companies or teams. So you don't want other people to be able to access that, or some information accidentally getting misdistributed because some query is wrong or something, right? Um, and you can have peak loads. Like, for example, when someone does an event and like 20, 30 people show up, you've got a lot of people logging in around the same time, performing a lot of actions, and you get these like peak loads that sometimes can be quite a bit to handle. How do we solve these? So for the real-time bidirectional communication, it's WebSockets. For high operational complexity, we've got microservices, which sometimes increases complexity, but for our case, I think it was quite effective. And then we've got something called a virtual private cloud, or a VPC, which is sort of like a network within the cloud that you can use to secure things up, which is very important. Also, a database per tenant, which means that every organization or space that gets created on Gozi has its own database. So if we've got 10,000 customers, then we've got 10,000 databases essentially. And this makes sure that we never sort of like cross share data or anything like that. Just physically. That automatically scale from zero to peak demands. You can adapt to customer needs faster than ever, which is great. So we went ahead and we started working with serverless. So before we get into serverless, I just want to explain real quick for the people who don't fully understand yet what is the difference between serverless and Docker, and how are they similar, right? So I'm going to start with Docker. And Docker is basically you've got your hardware, your operating system, then you may or may not have some sort of virtualization or container layer. Like if you want to, of course, you can deploy directly on your operating system and go from there. But recently, a lot of people are using some sort of container, usually Docker, to abstract that. And then they've got their runtime, for example, Node.js, and their code deployed. Um, and Docker kind of takes care of the rest, right? You're probably using something like ECS, Kubernetes, or an equivalent from Azure or Google to deploy and manage those containers if you're doing that. And then, yeah, it just runs out of the box and it's neat. And then if we're looking at Lambda, it takes it one step further. So it also serves the runtime for you. And it has a bunch of components that link directly to it. Because of the fact that your runtime is essentially running on serverless, and you've got a whole bunch of things like it's stateless, and Amazon is going to decide when to spin up your instances or not spin them up, or how to connect these things together. And they're doing all of that for you. So all you really end up deploying is your code, and of course, a whole bunch of configuration to make sure that everything else gets deployed automatically for you. So that's really the main difference, which means you have a bit less control over things, but everything does also become a lot more uh, easy to set up, and also like more secure, and all of these sort of goodies that you get from having a third party do it with you. So what was it like setting it up for the first time? It was exciting because, serverless and it's new, but there's a whole bunch of things. So first of all, WebSockets apparently not 100% reliable. Um, like if you're doing it with like HTTP calls rather than WebSockets, then I think it's gonna go a lot better for you. But yeah, you don't always get the events for when people disconnect. So you may be sending to a socket that isn't out there anymore, and then you get an error, and you need to sort of tackle that and make sure you don't try to send to these people again. Um, you have this thing that WebSockets need to be reconnected every hour, and you need to have a mechanism where you re-recognize the session of a previous. Which brings me to, there's no session because it's stateless, so you have to manage session yourself in a database somewhere. Um, VPC, it works, but it's slow. So specifically slow to start up there inside of the VPC, unfortunately, which is kind of a security requirement. Cron jobs kind of suck, but that was super important for us. I mean, it works well out of the box, but then there's some caveats. Setting up domains was not straightforward. So how you deploy this is you get this serverless config that looks like that, and it's really cool and really easy once you've got it set up right. And then it basically says when someone connects, you have to run this connect function that you define in your code somewhere, and that's really all it needs. And then you just have this config file, you've got your code, and then you just say serverless deploy, and it just deploys everything into the cloud, makes the lambdas, wires everything up, takes care of the writes and rolls, and you can even make it set up your VPC for you and all of that, which is great. Um, and once you've got it running, that's great. But if you want to couple that to a domain, basically what it's normally going to do is you deploy it, and then it's going to tell you, this is the URL we've deployed it to. So if people want to use it, that's where they should connect. But of course, you want to have a production API with the URL that doesn't change, and that kind of looks nice. So uh, adding that was kind of a stressor. We had cold starts, so that means that if the very first time your service is running, it's sort of starting up from scratch, and it can take several seconds for it to be up. So it's like you're making an HTTP request, and the first couple of seconds it's just starting up the server. And that's specifically slow in the VPC. If you do that outside of the VPC, it's less bad. But you can't stay connected to something like a queue or a database. So, for example, if you're firing up 3 Lambda functions, then they're going to connect to the database, do their thing, disconnect from the database, right? Essentially. Um, and if you're using async, which you're probably going to be using if you're doing node serverless WebSockets, event driven, and all of that, then yeah, if you have any unresolved threads, it's just going to kill them because it waits until the main thread resolves, and then it pauses the whole application, just puts it in the icebox until someone needs it again. And it might be that you still have a thread, then later on your application gets unfrozen and the rest of the thread executes, or it might just not even execute at all. So it's not exactly everything you were kind of hoping for. So we had all of these problems to kind of work around. But once we had it up and running, it felt like that. It was really nice to work with it. It was beautiful. Everything was like once we got past these problems, and all of them you could get past somewhat. And then we were really happy for I think 6 months, maybe 12. But then it started to hurt a little. Um, where's the session state? I think that was the one drawback with building it, that we had to implement session state ourselves. So we used Redis for that. But then scaling it, that's where our hearts really broke for serverless, because when you get 500 requests, Amazon prefers starting up 500 instances over waiting 0.05 seconds. And of course, if all of your instances are cold starting, then this can lead to this huge chain where it's just starting up loads and loads of instances. And that's not very nice. Now, Thing is, every concurrent request is a new instance. Every new instance needs a connection to the database, and so suddenly, like your 200 events come in, let's say on 1 second. So it's starting up 200 cold instances, and then after like 3 to 5 seconds, they're all booted up, and they try to connect to the database server, and the database server goes from 20 connections to 520 connections, and it just kind of dies, which slows everything down, and you get this big death loop, right? We were looking into solving that. Um, the problem is that serverless adapts really well to scale, but then it has its own sort of way of dealing with that on the infrastructure level, and there isn't, or at least on Amazon at the time, there wasn't a way to just create a connection pool and share those across different instances or something. Um, so what you want to do there is, yeah, basically that's what the database server looks like when you're trying to do that. It's not very nice. So yeah, it's scaling, but like everything else isn't. So what do you do? Surely there's a system in place for this, right? Yes, it's called throttling. So what's throttling? It's basically throwing away the rest. So you say, I don't want you to do more than 50 at a time. Like, don't have more than 50 instances. This means that no more than like maybe 40 instances are starting up at a time. So your database is never going to die. But then if it gets 55 requests and it only is allowed to start 50 instances, what does it do with the rest? It goes into the garbage. Just doesn't handle them, doesn't throw an error, nothing. It's just like gone. Um, so what about queuing? Why don't we queue these things so they don't get thrown away? So this is basically the architecture. I'm not going to go through this that they suggest for queuing things, but it's quite complex, and also it has a lot of delay attached to it. Um, and you've still got these cold starts. And even with this whole queuing mechanism, because we implemented something a little similar until we finally decided, this isn't going to scale. Like the throwing away behavior is still in there. Like you could maybe a cold start makes something takes too long to run, and there's a timeout, and the message still gets thrown away somewhere in the middle of a process. And it was really terrible, especially because we had microservices. So some services were sometimes talking to other services, not directly, but like over the bus, and then hoping to get some sort of a reply. And then sometimes things would just break down. Um, that was not really good. So reserved capacity, we also tried that. Like, oh, what if we always have 30 instances running, right? Even though usually there's just 4 to 5 requests just for those peak loads. It helps a little, but it only gets you so far. And we weren't we saw and we said, if we're going to double or quadruple our traffic, this isn't going to keep it. So what do? I guess we go back to Docker. Leaving serverless behind, I mean, there were some really great features in there that we're going to be missing. It wasn't working well for us, but like serverless is not a terrible technology. It just has its limitations. So load balancing is gone. WebSocket is gone. Auto scaling is kind of gone. So we needed replacements for all of these. Um, Load balancing can be done with application load balancer on Amazon. It's the same. So that was pretty straightforward. For the WebSocket handling, this is a kind of a tricky situation where, let's say you've got 5 servers and you've got 500 people connected to them with WebSockets, but I'm getting a message on server A and he needs to say something to someone who's connected to server B, then that becomes kind of a problem, right? Because they cannot directly send messages to people that aren't connected with them. So luckily, we've got a library called Socket.io, which is handling WebSockets for us. And you just tell it, like, here's a Redis URI, and then they all connect to it. And they make sure internally, magically, that whoever is connected where, they will get the message, right? Um, so for auto scaling, which was also like a very cool feature of Lambda, what we've got is ECS and Terraform. More on that later. And then SNS SQS. I'm sorry, I was kidding. You won't be missed. This was the internal communication platform that we used in order to be able to start up other Lambda functions easily, and we used as kind of a messaging system. But it was really quite terrible because the SQS connection couldn't be maintained, so it was super slow. And with SNS, you were only able to send messages, but not really able to get anything back. So all you can really do with that is send something, and it will forward it to a specific endpoint for you. And you can't really wait for a reply; it's just a void. So whenever we needed a reply, we'd have to use SQS, which was hella slow. So yeah, we switched over to Redis PubSub, which was a lot better for our use case as well. So we won't miss throttling, cold starts, high latency microservice calls, being boxed in by technology. I think this deserves a bit of a mention as well, because you're on there and then you're wondering like, can't I just use something like a connection pool for my databases, right? And Amazon doesn't support it, and it's not really possible for you to code it because you're in this stateless instance that can't really do anything, right? So this has to be provided to you outside of the platform, or you have to create some sort of service where you do this and then you connect to that service, right? But you end up feeling a little boxed in by technology. Either you leave the whole serverless thing behind and create your own thing that isn't serverless to connect with your serverless instances, um, or you just have to do it with whatever they've got available for you. We also won't miss the burning database server nor the hourly WebSocket reconnects. Um, so Socket IO is really great. They work in terms of rooms, which is really cool. So what you would do with Amazon, the only thing you could do is you had this identifier, like this is the identifier of the WebSocket. And if you want to send something to that WebSocket, then what you have to do is you have to make an HTTP post to an Amazon Web Service that says, I want to send this message to that guy, right? Um, and that was not really ideal. So if I had wanted to send message to 40 people on the floor, it would do 40 HTTP requests from Amazon to Amazon, which would then actually put the data on the WebSocket and forward it. And I really felt like that is not the implementation we were looking for, because HTTP requests take time and latency. It wasn't great. But now with Socket.io, you can just say, I've got this socket and they're connected to, this user ID in this room and this floor and this organization. And then on the application level, you can just say, I want to send this to that room or to that organization or to this specific user. And it doesn't matter how many connections that user has open or how many devices they're connected with, because if they are in, let's say, the room that's named after their user ID, then they will get that same message across all those connections. And yeah, Socket IO makes it sure that doesn't matter what server you're connected to, they will get it. So yeah, that was really beautiful, and we were kind of scared of losing that from Amazon, but Socket IO ended up bringing something even better to the table. Um, we used Terraform to replace serverless, right? Because we had the serverless framework, which we just had to say serverless deploy, and it deployed everything, and that was great. Um, and then to replace that, we got Terraform. It kind of looks like this. It reminded me of this guy just carrying the world. Like once you've got your Terraform config set up, and it was a bit tricky to set it up. I think we spent a couple of days fiddling with it because before it was right, but it was really easy to go, like copying a staging environment to a production environment, setting environment variables on the fly, making sure that everything has these things in place, making sure that all the infrastructure is correct, because it's such a pain in the ass to be setting these up manually or with CLI and making mistakes and then trying to figure out like what tiny component did I not configure correctly. But once you've got this Terraform thing running, like you can add another service super easily, or you can just go from staging to production. Or yeah, it's beautiful once you've got it set up. It's doing so much of the heavy lifting for you. And then Redis, I think, is a bit odd because at first Redis looked like really complex, but it's really super super simple. On one hand, I love the simplicity of it. On the other hand, it also feels like we're back in the 1980s and there's just mainframes, because the simplicity is great until you start getting into some parts of the nitty gritty. Like for example, if you're, I want to iterate over all of the keys in the database that start with this thing, then you better hope it doesn't get sharded somewhere, because then you need to make sure that uh, it's like, to stay performant, it's got a lot of the nitty gritty stuff that you really need to know and understand as soon as you get into these performance optimizations or do certain um, o- operations. So as long as you're just doing basics like get, set, or publish or subscribe or something like that, it's really straightforward, really easy, and it works so well. It's so fast out of the box. It's brilliant. But as soon as you get into some use cases that aren't even that crazy, you need to really start getting a deep understanding of Redis, or you will just not be able to figure out why sometimes it's like missing half the keys of your set, it's because the other half is on another shard and it doesn't query that way, and you have to force it to put all the keys of on start with a certain prefix on the same shard, for example, if you want to be able to query those. So like, yeah, there's a lot of these things, and they just don't tell you about that. You have to sort of like have that problem and then find out by yourself. Yeah, so that's a little bit scary. In conclusion, serverless, I think, is conceptually awesome. It's a really great solution, but it's still got a ways to go in terms of what you can do with it out of the box. It's really awesome for niche things like cron jobs, which didn't work out for us, but I think you can do that relatively well as long as you don't do a lot of cron jobs that do a lot of database connections and batch processing. So as long as the rest of the infrastructure scales with it, right? So this could be your database could give up because your serverless is overscaling, or other microservices might be having problems with it, or it could be slow because it has to reconnect with the queue every time. And like queues by default are very fast, but the connection establishing can take a little bit longer. So you need to make sure that you've got your infrastructure really ready to deal with this, or you're just fine with something taking a while to process, right? Or being queued in a certain way. Um, so when you look at it at first, it kind of just looks like the next evolution of Docker. And when I got into serverless, I felt like, oh, it's just like Docker, but even better. But don't underestimate what the stateless and the short running constraints bring with it, because otherwise you're going to end up, yeah, with sort of the same disillusions that we had. Still a pretty cool technology, but Lambda, if you're gonna throw away our stuff, then this is the unfortunate thing that we have to end up doing. It is what it is. So yeah, that was my talk on our story about Lambda and serverless. I hope you enjoyed it, and I'm open to questions.
Thank you, Sam. If anyone's got a question, feel free to unmute yourself and ask your question to Sam, or maybe you can also put it in the chat, or a direct message to Sam if you're feeling a little shy today. But hopefully there will be some questions. Anyone?
If no one goes, I'm gonna go. Would love to understand, Sam, what would have you done differently from day one if you, with all the knowledge that you have?
Specific to the story, I guess I would probably not have used Lambda from the start. That would have been very different. And yeah, the technologies I highlighted at the end, I would have used them from the get-go. Aside from that, I think really we went with an event-driven system, which worked very well with serverless, and it's working very well with us with Docker today. So event-driven and CQRS-like are things that I would definitely keep in place. Um, yeah, and microservices as well. I still think is a good fit with the problems we're tackling. But that more or less answers your question, right? Anyone else? Okay, cool. I'll pop into the cafe. If you want to speak to me, I'll be hanging out there. Anyone can just go there, hang out. Maybe you can meet someone. It's yeah, it's an open place. I'll be hanging out here for maybe the next half an hour or so, depending on whether people want to speak. So maybe I'll see you around, or maybe I'll see you next time.
Yes. Thanks, Sam. Yeah, for those of you who want to hang out, head over to the cafe or try some of the other rooms. Maybe you want to jump in the pool. Yeah, feel free to browse around and maybe have a little chat with some of the others in the space. Yes, so thank you, Kosy, for offering this amazing space for us today. We are in CodeMonk, we have Kosy as one of our partners, and if you are registered on the CodeMonk platform, you actually get a good offer. on the Kosy, so we will send you guys this after the event. And yeah, feel free to browse around, and maybe if you have questions for Sam later on, I'm sure he will be happy to take them. So yeah, thank you all for coming today.